Hello friends, I am Dr. Prof.Chishty and I am teaching physics to BSc third year students. My today's topic is vector atom model. In our previous models, we studied about the Bohr model, Bohr-Sommerfeld model. This Bohr-Sommerfeld model unable to explain the Zeeman effect. This model is unable to explain the Stokes effect. Means when the external electric and magnetic field is applied to the spectral lines, the spectral line will be splits into many lines. This effect was unable to explain by the Bohr's theory, and moreover Bohr's theory is applicable to a single electron. Therefore, it is necessary to study the vector atom model. So we know that in an atom there is a nucleus and the electrons are revolving around the nucleus in the circular orbit. Because of the circular motion of the electron, there is orbital angular momentum. And electron will rotate about their own axis. It is known as the spin angular momentum. So we can say that there are two types of angular momentum. One is orbital angular momentum vector L and another is spin angular momentum S. The resultant of these two is given by the parallelogram law of vector addition, that is along the diagonal J. So there is precision of the vector S around the J. There is precision of the vector L around the J. And if I apply the external electric or magnetic field perpendicular to it, then the J will precise. There is precision of J around the magnetic field vector or the electric field vector E. So this type of model is called as the vector atom model. Now here we have to study this model. So let us start with the orbital angular momentum. Orbital angular momentum. It is denoted by L. We can write the magnitude of this L using the formula. Magnitude of L is equal to square root of L into L plus 1 into h cross, where this L is called as the orbital quantum number. Small l is called as orbital quantum number. The value of L will be 0, 1, 2, 3 and so on. So now we can write the component of L along the z axis, that is Lz is equal to ml into h cross, where this ml is called as orbital magnetic quantum number. ml is called as orbital magnetic quantum number. Okay. The value of ml will vary from plus L to minus L or minus L to plus L. Value of ml will vary from minus L to plus L. Now similarly, we can explain the spin angular momentum. Spin angular momentum vector, it is denoted by S. Spin angular momentum vector, it is denoted by S. Now the vector S, magnitude of S is root over S into S plus 1 into h cross, where this value of S will vary as value of S will vary as half, or it is equal to half. Now we can write the perpendicular component, that is magnitude of S along the z axis, as ms into h cross, where this h cross is h upon 2 pi, where h is a Planck's constant. The value of ms will vary from minus s to plus s. Value of ms will vary from minus s to plus s. That is, ms may be minus half or ms may be plus half. Okay. So we are having the two types of the angular momentum. One is orbital angular momentum and another is spin angular momentum. We can combine these two as vector j. Total angular momentum vector j is equal to vector L plus vector S. L plus S. Vector sum. Vector sum is L plus S. And now we will find the total angular momentum by combining these two. So I will find here the total angular momentum. Total angular momentum vector j. And magnitude of j can be written as root over j into j plus 1 h cross. J into j plus 1 h cross, where this j is called as the inner quantum number. This j is called as inner quantum number. Value of this j, value of or the perpendicular component of this j, first we will write it as jz is equal to mj into h cross. This mj is called as the magnetic quantum number. It is called as magnetic quantum number. Value of mj will vary from minus j to plus j. Minus j to plus j. Value of mj will vary from minus j to plus j. Now if I combine or if I write the magnitude of jz, magnitude of j along z axis as jz, it may be Lz plus minus Sz. Lz plus minus Sz means we can say that mzj, mz into mj into h cross is equal to ml into h cross plus minus ms into h cross. This h cross get cancelled. You will say mj is equal to ml plus minus ms. ml plus minus ms. Or the maximum value of mj, maximum is equal to plus j. Value of maximum value of ml is plus l, and the value of maximum value of ms is plus s. Now we can say that j is equal to l plus minus s. If I write here j is equal to l plus s and j is equal to l minus s. In this case, value of l is from 0, 1, 2, 3 and so on. S is half. It means that vector j will be greater than l, and here the vector j will be less than l. So we can draw the vectors in these two cases, j when j is greater than l and when j is more than l. So we can write here the vector l, and here is the vector s. And I will use the triangle law of vector addition by drawing this, the third vector, as j. So you can see in this diagram that here is j is greater than l, means this condition holds good. Now for j less than l, I will write here, I will draw here the vector l and vector s. Again I will use here the parallelogram law, triangle law of vector addition. That is, the resultant is j vector, and from the figure you can see that j is less than l. So this is the vector representation. Now if there is spin orbit interaction, if I draw here the spin orbit interaction, then I will draw here the vector L, orbital angular momentum, spin angular momentum. I will complete the parallelogram, and the resultant is given by the diagonal of the parallelogram. So here there is the precision of s around j, there is precision of the vector L around j. So this is called as the vector atom model. Now if I apply the external magnetic field in this diagram, here is vector L, here is vector S. The resultant of these two is along J. I am drawing a perpendicular electric or magnetic field vector. So there is precision of S along J, there is precision of L along J, and there is precision of this resultant vector J along the external magnetic field vector B. So this model is called as the vector atom model. We can find the angle between these two vectors L and S. This angle can be found out by taking the dot product of the two vectors as J dot J is equal to L plus S dot L plus S vectors, and we can find the angle between the two vectors. It is the spin angular momentum and orbital angular momentum. Thank you.